Hello, everyone. Thank you so much for joining today. Uh, so I'm Vandana, and let's start with the webinar. Yeah. So for those of you who are new here, I'll tell you a little about us. So Sierra Circuits is a one-stop solution for PCB fabrication, assembly, and component management services. We have a 70,000 square feet PCB manufacturing and assembly campus in Sunnyvale, California. We also offer advanced technologies like HDI, rigid flex PCBs, RF, and microwave PCBs. So this is the agenda for today, and we'll be going into all of these one by one. To understand the significance of RF PCB design, it's important to see, where the market is headed. So here is a brief overview of the RF PCB market size. Uh, So the global RF and microwave PCB market was valued at 1.588 billion US dollars in 2024, and it is expected to reach 2.23 billion US dollars in 2029. It is forecasted to grow at a CAGR of 7.02% from 2024 to 2029. So now let's get to the core topic. So we'll be discussing the four factors for selecting antennas for RF PCBs first. The first factor is the antenna gain. So antenna gain measures how well the antenna directs RF energy in a specific direction compared to an isotropic radiator. It's expressed in decibels relative to isotropic radiation. Higher gain antennas focus energy in a specific direction, hence increasing the range, but it reduces the coverage in other areas. And lower gain antennas offer a wider radiation pattern, and hence they make them suitable for omnidirectional applications. Let's move on to antenna bandwidth. Bandwidth is the range of frequencies over which an antenna can operate efficiently without significant signal loss, and it's measured in megahertz or gigahertz. The bandwidth is determined by the lower and the upper frequencies at which the VSWR meets the 2:1 limit. The antenna must cover the entire frequency band of your application. For example, 2.4 gigahertz for Wi-Fi or Bluetooth, and 868 915 megahertz for LoRa. Also, wideband antennas like log periodic or UWB antennas support multiple frequencies, but may be larger in size. So even with the right gain and bandwidth, your antenna's performance depends on how sensitive the receiver is to incoming signals. So the receiver's sensitivity refers to the minimum signal power level that the receiver can detect, and it's measured in decibel milliwatt. If the receiver has a high sensitivity, then it can operate with a weaker signal, but you must match the antenna to the receiver's sensitivity to ensure reliability with minimal power consumption. If the antenna doesn't deliver enough signal strength to meet the receiver's sensitivity, then the link might drop. For instance, the Bluetooth low energy receivers typically have a sensitivity of around minus 90 decibel milliwatt to minus 10 decibel milliwatt. So size plays a crucial